This is Mr. Mix with another video on coordinate geometry. This one is particularly found in the AS level textbook, the book Y equals mx plus c. You will find this on page 131. That's Try 21 question 2. If you don't have access to this book though, you can just follow the question, and of course you have the luxury of pausing the video and try to solve this question on your own. Alright, so you have got the diagram here. It shows a rhombus A, B, C, D, and point A is -1,2, point C is 5,4, and then point B lies on the y-axis. Now, when a point lies on the y-axis, it's very important that you understand that the x coordinate is going to be 0, and we only need to find what the y coordinate would be. Okay, because the y-axis is also the equation x equal to 0. So every point on the y-axis will have a 0 value for its x coordinate. So what they are saying, they're saying we're supposed to find the equation of the perpendicular bisector of AC. So basically, what they ask us to find is the equation BD. So they are actually looking for this equation over here, BD. Okay, just if my line is not so proper, I think you get the idea. Right, so that's what we're actually supposed to find. We're supposed to find equation BD. Also, another thing with knowing is that in order for us to find that equation, we also need to take into consideration the points, or the points A and C. So what we're now looking for is the gradient. So another thing that you also need to take into account is that the diagonals of a rhombus, okay, at the point where they meet, they do create this 90 degrees. So if we can find whatever the gradient of AC is, we will have to see that the gradient of BD will be the opposite of that with an opposite sign, okay, or the reverse of that for the opposite sign. So basically, this leaves me with the same where I calculated something before. So we find the gradient of AC, and always take note of your points so you don't make a mistake. It's very easy to make a mistake. So the gradient of AC is going to be 4 minus 2 upon 5 minus -1. Okay, so that gives you 2 over 6, which is basically a third. So therefore, the gradient of the perpendicular bisector, or if I have to put it bluntly, the gradient of BD, should equal to opposite side, which is -3, as we multiply these two, you get a product of -1. Another point also is going to be us finding this midpoint. So the midpoint is calculated by the midpoint of AC. We calculate it by simply saying the 2x values, half of it, the mean, and then we also take the 2y values, in this case, which is 2 plus 4, and half of it. Okay, so 2 plus 4 and half of it. Okay, so this gives me that the point is 2, 3. So that point here is the point 2, 3. So why is that important? Because now I can actually calculate or write down the equation of the perpendicular bisector of AC, or the equation of BD. So the equation of the perpendicular bisector of AC, which is also finding the equation of line BD, is y minus 3 equals to the gradient x minus 2. So basically I'm using this point here and into the formula. I hope you're also familiar with that formula. Where you have a point and the gradient, then you can definitely find the equation. Okay, right, so the equation is going to be y minus 3 equals to negative 3x plus 6. Just be careful, once you do your distribution here, you're going to have a negative times a negative, give you a positive number. So the equation here will therefore be, the equation will be y equals to minus 3x plus 9. So that's the equation, and that is the um, solution to that problem that we were supposed to find. Okay, the next one says point B. Find the coordinates of point B as well as the coordinates of point D. Right, so from before, when I started the video, I already said that the x coordinate here is 0, and our job is to find the y coordinate. Okay, right, so since point B that lies on BD, now you must understand B lies on BD, and we know the equation of BD from our work before was y equals to minus 3x plus 9, and since B lies on BD, we also know, and also since x equals to 0, we can actually find or calculate by saying, okay, that means y equals negative 3 plus 9, where the x value is now 0. Well, this gives us the value of 9, of y, which is 9. So therefore that here becomes 0, 9. You got it? Okay. So that is the coordinates of B. So the coordinates of B is 0, 9. Now the next one that we need to find is the coordinates of D. Now, once we get to D, perhaps I can write here that the value of D is x, y. Okay, and it's something very important that you need to understand, is that if you look at our point D, which I will say is x, y, and also our point, looking at our point A, I want to bring all my points here, negative 1, 2, and then also looking at our point C. Our point C is 5, 4, and then we also have our point D, which is not point D, because we already wrote point D, our point B right on top there, our point B, which is 0, 9. So what does that give me? Well, I'm just going to come down here. You'll see that I've completed the diagram, but I'm not going to bring it all up because I want to solve this problem first. So we can then say that vector BA equals vector CD, and BA, now you have to be very consistent here when you are solving this. So the x value is negative 1 minus 0 and 2 minus 9 should equal to x minus 5 over y minus 4. Okay, so of course this can also be written another way. If you were to do, you'll get to the same answer. Someone else could also say, okay, or someone else could also say, you could write it like this. You could say 0 minus negative 1, and 9 minus 2 is equal to 5 minus x and 4 minus y. Well, this is still the same of AB equals to DC. Anyway, basically what that means, if I go to AB, if you look at the distance from A to B, so we are now talking about this distance here. When you are comparing the vertical distance from here all the way up to here, you will realize that it must be 9 minus 2. This vertical distance here has to be 7. And when you compare this distance here, well, that has to be your x value, which is going to be 0 minus 1. So this distance is just 1 unit. That's basically what we're looking at. Okay, so we are now equating that to um, to CD, because these are parallel sides and therefore they are equal also in length. Okay, so all these distances are equal. Since I'm looking for this, CD is equal to BA or AB. Okay, so whatever distance we are getting there should also equate the same. So we then also do the same by applying that same concept, where you can say, okay, here, if I want to find the y values, I'm going to say, okay, it can be 4 minus y. Compare that with this distance here, which is nothing else but 5 minus x. All right, 5 minus x. Okay, so basically that is what we are looking at when I am now doing this problem here, trying to use the vectors, equivalent vectors there, because the sides being equal. Okay, so let's work the problem that we have. Again, you will see my diagram a bit later nicely. So this is here. On top is going to be negative 1 equals x minus 5. And if you work this out, you will have x equals to negative 1 plus 5. Therefore, x equals to 4. And at the same time, if you are now doing the comparison for the y values, the y values would be 2 minus 9 equals y minus 4, and that's 7 if you to negative 7, and you have y minus 4. Therefore, if you then work it out, you will see that y should equal to negative 7 plus 4, which is y, and therefore the value of y is negative 3. Okay, so that then gives us that the point D must be the point 4 comma negative 3. As you can see in my diagram, point D is the point 4 comma negative 3. Okay, so it's also indicated here in the diagram. Okay, so a little bit of work using also your knowledge of vectors in order for you to be able to calculate that. Right, so that last part they are saying find the area of the rhombus. Now, also something you understand, we need to work the diagonals of a rhombus. So basically, if I have to bring it in, so we are going to look at distance AC. So we are going to look at that, and BD, all right, and we are going to take those distances. What is the actual distance? Now that we know all the full coordinates, we're going to use the distance formula, and you find that distance multiplied. So multiply BD, the distance of BD, times the distance of AC, and find half of it. Okay, right. So let's write down what I have from our previous work so that you can just follow. So I'm going to do the distance of AC. So my point A is negative 1 comma 2, and my point C is 5 comma 4. Right, so if you calculate the distance, you're going to have 5 minus negative 1 all squared plus, of course, 4 minus 2 all squared. Right, so AC is going to be, that is going to be 6 squared plus 2 squared. So here you have 36 plus 4, which gives me root 40. I'm going to leave it like that. Then I'm going to find BD, the distance BD. Again, my point B is 0, 9, and my point D is 4, negative 3. Okay, so that means I'm going to say 0 minus 4 all squared plus 9 minus negative 3 all squared. Okay, so that gives me nothing but 4 squared here, and then that is going to be positive 12, and eventually this gives me nothing but 16 plus 144. Okay, let's just go down so we can have more space. Therefore, BD is going to be the root 60. So that is 160 units, and that's for the root 40 units. Now, to find the area formula is the area of a rhombus is a half times the first diagonal times the second diagonal, so it's a half times root 40 times root 160, and this is going to be square units since we are now looking for our answer is an area. So the answer will be nothing but 40 units squared. Okay, and that will be the distance, or that will be the area of the rhombus. Okay, interesting question. Please do try it on your own before you have a look and see what is it that I'm doing. Eventually, you should definitely get to the same answers. Right, so stand by for a request that was given to me on my channel where someone asked me to explain transformations of transformation of functions. So I'm going to do this. This is more like a lesson that now will be a sort of just information sharing, the behavior of functions and such. So perhaps you can go to those pages there in your textbook, or you can follow what I'm doing. Okay, so if you have WhatsApp groups of your schools and you are probably looking for these nodes and you want to use it, you can definitely also contact me, and I will gladly share the notes of this with you.